Okay, so this time let's implement concat and substring for like the standard library of the language. And yeah, I mean we are pretty close. We just have to implement these two things, and then we'll be able to, I guess, let's just take a look. Just run the real test case. That's like the complete program in our language. And yeah, I guess how that looks like. Just again as an update, like a Java. Yeah, it's like a Java style language, right? With objects and methods. And yeah, we so far we did like the entire front end, the intermediate representation, and the assembler. That's what we are trying to finish right now with the concat. And I guess I haven't used substring in this one, but I mean, we implement that also. So yeah, let's go into this one and let's see. I mean, we still have to do, if we check in main, some error handlings like exceptions, but I think, I don't know, I yeah, I mean those are like edge cases and stuff, so we'll have to see. But like for extensions of the language, I would really like to be able to have like something like syscalls, right? Be able to have like a Linux class, and yeah, that's gonna allow us to work with the memory, I guess, and be able to, I don't know, have a better standard library somehow. Like, because right now, when we want to add a function in the standard library, we have to make it in assembly, and that kind of sucks because it's kind of difficult. But yeah, and then to implement a better build system, that would be just rewriting the main function. And yeah, we should like allow you to read from multiple files and report the error from again multiple files and stuff. Have these paths be somehow taken from the environment or something like that. Now search for the library inside of the path, I guess. And yeah, basically search for the cool prelude in path, and reading these files from there. And yeah, like the rest of the compiler is done. So like, I guess the C code from here is pretty much done, right? So let's go back to the assembly. Okay, so I didn't add it to do. Let's go to concat. So similar to length, let's just copy paste the initial body, right? So the idea of concat is we're gonna have two string objects. One is gonna be in the A register, the other one will be on the stack. And yeah, we want to add the contents from the second string to the first one. Okay, so yeah, that's what we need to do. So I guess the first step would be to, well, actually we want to modify the first string. We are gonna create a new one. It's also kind of immutable kind of language where you always create new expressions in some sort like a functional language. But yeah, so I guess the first thing would be to get the length of the both strings that we want to concatenate. So how do we do that? Well, we can use string length for that. So yeah. Okay, so let's see. So we can move into ArrayX. I guess, yeah, also the first thing, let's create some local variables. Let's remove them. I mean, we'll see how many we need. 5 variables is enough for everything, I guess. So I guess the first thing is to create a new string, right? So let's do that. Let's call copy, and this thing will also allocate the memory. Yeah, it will try to allocate memory if we don't have enough, but we are still gonna need to check that, because when we are gonna add the two strings, we might have to allocate more memory. So it's gonna be similar to reading the string. So, but anyway, let's continue. Uh, where was I? So concat. So here we create a new string. Okay, let's actually save it. Right, t1 is gonna be the length of self. So let's move into ArrayX rbx. Then we call string length, and I guess here let's see. Mm, I think that actually I would rather create a new integer first. That's gonna have the sum. So new int prot object, call object.copy, int init, and let's move it. Then in t2, let's take the value of this thing. So it's gonna be, as usual, we need the self. We always keep the self in rbx, and we never change rbx. So that's why we have to push it here, and then we save self into rbx, and then at the end we pop that register, so we restore it. So while we are inside of the body of the function, rbx is going to be self, and the point is to not modify it. So we go to the string size, right? Now we take the, so basically here we take the self, we add string size to it, so that means we got the address to this thing. If we dereference that address, we are gonna get an int object, and now we can add the int slot to go to the address of val, and now we can actually get the value. Perfect. And yeah, this should do that. And now t3 should be the first argument. So here, instead of taking it from rbx, we take it from rbb plus arg0. I created this like a small macro just to, I mean it's 16, but to not confuse it with other stuff. And this is like also, I think it's, yeah, 32, the fourth variable basically. But yeah, now we have all of these things. So let's say we are gonna do something like t1. First, I guess we can compute the t4. as the sum of both of them. So let's take the second variable, let's add the third one, and then let's move it into T4. So yeah, it's really cool that there is so much assembly like this in the file that Copilot already knows just by this comment what to do. Okay, so we have T4, and now we want to set basically we want to set I mean I would like to set the value of T1 to that, but now should be the place to do allocation in case we need it. So let's see. I wanted to mm, to see something like object.copy where is defined, because we are gonna need this stuff, something like this. So here we need to compare T4 with the end of the heap, right? I mean not T4. So actually let's do T5 is gonna be the start of the string, I guess. Mm. Yeah, it works like that, to have the start of the string. Address of the start of the string plus T4, I would say. And this would be the place where our string will end, right? That's what I'm thinking. Something similar to this. This is a start pointer, then we were getting this value. Interesting that here, I mean this is init. I wanted to see in string because that's more interesting. Like we see we are getting the pointer to start, and here we need to compare that pointer plus what we read is smaller than the heap end. So we have to do this comparison basically. Right, something like this. So we need to take this. This will be the start of the string. I mean, I guess maybe we want to keep that address. I don't know though, I don't think so. I don't really see why. Because we already know the length, so we don't need it for length, right? Yeah, I don't think we need it. I think we need it only once. So we need to take the first variable like this, right? Then we need to add the string field to it, and this gives us, I guess, the pointer to that. So I guess, yeah, it's gonna be like a pointer, right? Or is it the very straight up? I think it's the very straight up. Maybe. I mean, we'll have to see. Let me just check the string prot object. Yeah, to be fair, I don't know yet. I mean, we'll see. But here it looks like I took the address and just like string field was the address. But for some reason it doesn't really look right. Because it looks like if we read to that position it's gonna overwrite stuff. But maybe since it's the last thing that was allocated, it's gonna be fine actually. Yeah, I guess so. I guess that's the way to do it. Move this thing around. And this should be T1. So yeah, let's just keep it like this. Because I think that the string contains the entire string inside of the object itself. It's not really a pointer anymore. So yeah. So here we need to take from location 1, we take the variable that we just created. We take the address of the string, which is an array of bytes. Here we were saving it in the inString function, but I think that we can just add the fourth variable here, like the length, and then we store that. Although we don't even need to store that. We can just compare it to heap end. So we just have to add heap end to it. Or I meant we added d4 and then we compare to heap end. And if it's like this, we do that. Otherwise, we have to allocate some bytes, right? With sbreak. And if we are smaller than the heap end, then we can go to copy, which I guess should be named something else, but yeah, like concat. Okay, concat or something, I don't know. Yeah. And in this one, I guess what we have to do is to use memcopy. So memcopy works like this. Let's go back to this thing. So here we actually have enough memory, right? So to use memcopy, we want to have in RDI the destination. So yeah, not really. The destination is gonna be X destination is gonna be the pointer to S like we did here. So we need to take something like this, right? We take RDI is the destination, RSI is self S. Yeah, anything like that. So self L value is T2, we have it. But here I said we take the first variable, we take the string field, and here we need to move rocks into RDI. That gives us the first argument, the destination. Next is to move into array X self. Then we need to add a string field, and we have to move into RSI the A register. Easy. And the last one is to just take, I guess let's just use RSI here and RDI here. So it's less code. And RDX is the length of self. So I think that should give us the copy, right? To like we copy the first thing, then RDI is gonna be T1 S plus the length. Then we're gonna do this and this. So here it's similar, but we also have to add location 2, right? Just to move the pointer by this amount. Then we have to put the first argument in RSI and add the string field. And for RDX is gonna be, I think, the third variable. Yeah, third variable had this. And now we can call to memcopy. Right, so at this point t1.s should have the entire string. That's good. We just have to say that t1.l is equal to t4. But first we need to put into t0 the length, so t0.value. t0.value is equal to t4. So we need to take this one, we need to take the int slot, address to int slot. Then we need to move into RDI. We cannot use RX again. We have to move the first variable there, and then we move to RX, we move RDI, like this. So we set the value of T0, and finally T1.length. So we take the T1 variable, we go to string size, and we should take the first variable, I guess, yeah, like this. So it's the same thing, or at least it's similar, right? And let's see what this function needs to return. RAX is the new string. So I guess at the end we need to move into RAX this variable T1. I guess that that's enough. So we used 5 variables. That was precisely 4. Pretty strange. I mean, I wanted to use more, but I was like, okay, let's try to be limited. Okay, so let's, check the tests, right? Because at least in the tests we know what we need to return. So 19 concat. Hello W. Hmm. I'm pretty sure, yeah, this thing returns quite a lot of stuff. I mean, I should have had a simpler example at first. Maybe this was a bit too much for... yeah, let's do something like this and see what it returns. Okay. I mean, the only way to actually see what happens would be to, actually go step by step. So yeah, as I said, let's just have a really simple example first. Like just printing the message. Maybe like concat a new line to it or something. Like that's enough to see what happens, to be honest. Okay, I have no... what? Oh, I need one more parenthesis. Okay. So like this is enough to see what, if it works or not. So let's go as usual, some GDB debugging. So I guess the only thing we're gonna do is concatenate. So let's see. I guess this is the concat, so let's see. So here we add 28. Let's see if 28 in is 50. It's 40, yeah. Perfect. So we create the variables. Just save RBX. Here we create a copy for an int, so let's keep that, it's gonna work. Here we create a copy for the string. This is the int. So we put the copy there. Right. And now what was the first step? The first step was to get the length of self. So that should be like what, 12? Let's keep a Python shell open. So we have something like hello world. Yeah, it's actually 12. So there I see we took the integer value, and yeah, it's zero. It's C, which is 12. So that's good. we store that value. Then we take the first argument. Okay. And again we take the integer, and it has value of 1, so we store that. After that we do the addition, so we should see like what, 0, like D, right? Well, let's first check. Yeah, so we take that value, we add that one, and we get D, so we store that also. In T4. So now let's see what happens when we are gonna compare like what, T2 and T3. And TS1. So yeah, this should be okay, so that's the address of the string, I guess, where we are gonna write. So add that. And we have to compare with something that's pretty huge. So it's gonna jump, it's not gonna require malloc. So it goes here, and now in RDI we wanted to have the TS1. So let's see if we are gonna get TS1. So in RDI we should have, yeah, 70, and in RSI we should have the start, which would be hello, right? Hello world. And in RDX we are gonna have the length. So that's okay. So guest arguments will be like this. So I would like to not go into memcopy. But what we know about it is that now we should have hello world in our in this variable. So if we examine like what, 40 hex from here, we should see something like this is a string. It has size 5, whatever, the dispatch table, the int size, and this is the value inside of it. Right, so it's 65, 48, 6C, 6C. So I guess if we take a look at what or RD or CHR48 is, but it's in hex, so it's hello. So we actually have the string here. Let's try to examine string ut. So we see hello world in our in the data, so that's really nice. So now we put in RDI, we put again our variable, we add that, so we see hello world, and now we should add this, so it points to 0. Perfect. In RSI we put the argument, so it's gonna be here, we're gonna see a new line, yeah, in RDX we need to put the length of 1. So again, like this. Now if we break here, we continue. If we check again the string from here, it should be hello world new line, and it is. That's really good. Okay, so we know that this part works. Let's see, maybe this doesn't work. So T0, we take T0 into RAX, we take its pointer to the value. In RDI we put the total length, which is 13, and now we set the value, so it works. So it looks like it works. Like if we check this thing, if we examine again 40 hex or whatever, we're gonna see it's an integer. The size of the integer is 4. This is the dispatch table, and this is the value, 0D. So it looks like it works. Now we take pointer to T1, right? We add the size, so we should see it's a 0, but doesn't really matter. In RDI we put the first variable, so like that, and we move that address RDI. So if we move it, yeah, and now if we take a look at this thing, so if we examine 40 from here, we should see again, it's a string, it has size of 5 bytes, although it's not really 5 bytes because of the string, but yeah, I haven't thought about that. Yeah, like maybe the size, yeah, I don't know, but here you see we have the address to the int. I guess we forgot to move the, yeah, I don't know. So here is this one. So it still looks good. 42, 60, 50, or 30. Yeah. So it's actually okay. So in that one we put that. We delete all the local variables, pop RBP, and we return. And now we put, well, I guess now it goes to the code. So we stored I mean, I guess if we take a look at examine 40 hex here, at this address we still have hello world. I guess we didn't move the end of the heap. So like here, let's say we are gonna breakpoint here. This might overwrite our data. Yeah. So I think we also need to move. So let's see when we do outstring. Oh, I meant in string. We didn't update the heap end. I mean heap end, yeah, it's not really gonna update. But yeah, I don't get why this would work. Maybe this is also bugged, so just have to keep that in mind. Like the issue is that we I guess we can take a look at the assembly itself. So where how we store the strings is we put the type tag, the object size, which is not really right. It probably should change based on this, but I don't know. Then we have the dispatch table, like in any other type of object, the pointer to the int object, and then the bytes of the string. And the issue is that when we allocate a string, we only keep the first 8 bytes, because after that the like here is where the allocator stops, because it knows that it has to allocate 5 bytes, right, for a string, or I mean 5 words. But yeah, I'm thinking that this should be bytes. It shouldn't be like a pointer or something, so it should be the bytes. I guess the object size is not really right. So another way to do it might be just to increase the start. So here we allocate a string, right, when we do in string. But I don't see where we modify, the heap start. So let's see where I mean, it should be heap start. Okay, let's search for heap. Okay, it's heap position. So here when we do object copy, we add to heap position T2, which is just the size of the object, and as I said, size of the object is that number in bytes. So it's not really enough for strings. Yeah, it's not really enough for strings. So yeah, I guess we'll have to change the logic a bit and modify the size of the strings to actually represent the size. But for now, we can do a hack, I guess. I mean, sure, it's gonna be a hack either way. Um, because we just need to increase the location. So here, for example, when we do copy, we might want to write object.copy, especially when we work with strings. we might want to change on the prototype object the size in bytes. But the problem is, for example, here, we don't know what that size will be. But yeah, we don't really want to change it also because I mean we cannot change it though. But I mean we can change it on the final object. Why not? Right? Like what we can do is yeah, I mean it sucks though. But yeah, it's still possible to do it, I guess. Yeah, I'll just have to think about it. Right now, let's not, because it would be easy if object copy did all the work. I mean, we can try to take a look at the implementation from MIPS object.copy. Although it's ugly as shit. So here it just did object size. So not really. But let's see string.concat. So it just did the same thing as we did. Or I guess, yeah, I mean, it's the same thing. String size. Ah, I see. It actually copied this thing. Here it copied itself. It didn't really copy the... that's actually pretty smart. I didn't realize that we can do that. That we can actually duplicate an object. Yeah, that's actually a really good point. It calculated a new size. Then did allocation and stuff. The end of the first string. Size of the second string. And here, yeah, it realigned the heap pointer. So yeah, that's what we have to do actually. Just move it by hand, I guess. That's kind of meh. I mean, that's yeah. Anyway. But yeah, that's a really good point. How about like not having to create new objects from scratch and copying like this? But yeah, I'll do it after. So I mean, let's just do it. Let's just do it. So instead of doing like a completely new integer, we can have something like move into rax, we move rbx. So let's say self.l.copy rbx, we move into, well, we add string size. Then we call to copy. We don't even need to call init. Yeah, we don't even need to call init. Yeah, let's leave it like it was. So here we get, but that's gonna happen at the end. So update heap position. So yeah, here we need to update the heap position. So that's like, I mean, we have that thing that we computed here, T1S plus. So it's this. Right, we need this thing. Yeah, that's why we needed to save it. Okay, let's see if it works though. Like if it works, I'll change it to nice. So it works. But doesn't work on the because I changed the 19 one. Okay, so perfect. It actually works. Let's just make a checkpoint. And let's do it like they did it here. I mean, I guess if it works, it works. Why change it, right? The only extra thing that we have to do now that we got here would be to update the object size. So we need variable 4 for that. Actually, we have the, no. I thought, I guess we can subtract from this thing, we can subtract the heap start to get, so we can do sub. Okay, let's put this in a variable. So we need to allocate 48, so it's gonna be 6 variables. So here let's store this one in T5. So T5 is gonna be T1.s plus T4 right? And here we compare T5 with. So here we move it into T5 and here we take it back. Okay, perfect. So now we have the ending of the string and the beginning of the string. So if we subtract those two, we get the size in bytes. So here we want to update the heap position, so we use that. But before that, we want to update string size. So I mean, we can do something like size of t1 is equal to t5 minus t1 dot s, right? t5 is the end of the string, right? Yeah. Well, not really. Minus t1, right? T1 is the address of the variable. That's what we need. So we move t1 into rex. Now we move t5 into this. We subtract the first one. I guess we need to, let's see, because it needs to be divided by 4, but it has to be aligned somehow. I don't know. Let's just divide by 4 or by 8 because we have, yeah, so we shift, no, it's shift right. I mean, let's do like this. So we shift right by 3. Yeah. Okay, maybe another variable just for this. So to make it easier. Although it's not even needed. We are gonna move it in RDI or something. So we move RDI RX. Then we take this. We go to its object size. We go to object size and we update that size there. And we might have to do that for all of the strings. But yeah, anyway. So this should also update the string size. But yeah, I mean, the funny thing is that we don't even use the size anywhere anyways. I mean, unless we do object copy, that's when we use it. So let's see. Fix add update string size on concat. But we might have to update it also on reading. So in string. And we also need to update the heap position. So let's see. Let's copy these two. So in string at the end here, we need to update the size of t1, and let's see, t1 is the string. Perfect. We have the address, if I remember correctly, t2 is gonna be like the beginning, right? And the t3 is gonna be the end of the string or something. Well, yeah, right? So t3 is gonna be the last. I guess t4 also is the string length. Yeah, t4 is the string length. So yeah, I guess that means that t3 is an address on the last byte of the string. So we can do t3 minus heap position to get the size, or t3 minus t1 actually. And here when we did concat, t5 was the last one. Okay, so here t3 is the last one, I think. t3 is the last one. Yeah, so this should probably work just like this. It's pretty nice, we don't even have to change that much. So we also update the size, that's good. Then we have to update the heap position, which should be t3, like the last one, last byte. But I have a feeling that it should be plus one more or something. Okay, so let's do it like this. Basically we subtract this thing, but I feel like we should also add a 7 to it to align it. Right, if we add, like if we do something like, let's say the length of our string is 3, so if we divide by 8 it's gonna be 0. That's not good. But if we add 7 to it, up until 7 is gonna be 1. But when we increase to 9 it's gonna get 2. When we do 8 it's still gonna be 1. So yeah, I think we have to add 7 plus 7. So add RAX7 just for alignment. Right, so this gives us the size. Okay, in bytes. So we might want to move the heap start not necessarily by 3, like by location 3 or whatever this is gonna be like, but by the number that we did here, so by this thing. So that thing right there, t3 minus t1, is the offset that we need to add to heap position. I mean, I guess I would add a new variable just for it. We'll do 48, 5 variables. Here we need to change to 48. So let's say t5 is going to be equal to this. Move Rx, so this should be t5. The size changes like that. And here heap position is heap position plus t5. So let's take this, and here we need to add to heap position that value. I think this should be better. Not exactly. We want to shift right RAX and then shift left. Is this stupid to do? Like, this should give us the aligned version by 8. Yeah, anyway, let's copy this thing. Let's go to concat. So for concat we allocated 6 variables. Okay, it's the same thing. But yeah, here at the end we do that. Here we need to subtract 48. So we need to do t5, r5. But yeah, I think we need a new variable, t6. So this should be 56. I don't even know if I have enough variables, constants. Log 6 and maybe log 7. So here we create this thing. So yeah, now we store the size. That's pretty good. And here we need to add this much. I think these are the only two places where we need to change the size in bytes of a string object. Probably there's there's gonna be one more in the substring. But yeah, like here, to be more efficient, you can copy your int or already existing int object and string object or something like that. And it's gonna be a bit shorter, but I mean, who cares? If it works, right? Like, it's important to work. So yeah, the last thing that I would have to do, so since we started on this path is when we do the const values. Const. Here I hard coded 5. But as we saw, it should be like variable. So let's take the string length, put it here. Size t words. I guess we can try to do the same logic. So we have the string length, which is like this. We add 7, shift, shift. It's gonna be length plus 7, well, plus word size minus 1. And we divide by word size. And that should give us the number of words. So we have tag, that's one. We have the size, that's the second. The dispatch, so it's gonna be 4 plus words. I thought it's gonna be 4 because we have the type tag for one, the object size for the second one, dispatch table the third word, and this is the fourth word. No. Let's see if this changes anywhere in the string constants. Here, for example, it's 6. Let's see if it really is 6. So we have 1, 2, 3, 4, 5, and this is the 6th, which only has half of it filled, but it's still filled nonetheless, so it's 6. Okay. So I think this fixes the issue with string alignment. I don't think there's, let me think if there is any other place where string alignment can be an issue. I don't think so. Like, we handle that in the constants, when we read the string, and when we concatenate the string. We don't have any other place where we fuck around with the strings, you know. So fix this is like string align or something. Okay, so the last thing is, and yeah, the last thing would be substring, which actually I don't think it's, I think it's obviously easier than concat. So let's start with, let's start with the usual. Like, let's just copy this part. Do the same thing. Create a new int, create a new string. Okay, let's do let's see what else we can scavenge from concat. I don't think we care about the length. I mean, yeah, for error handling, but not yet. let's take, yeah, something like this into our next variable. Let's have t2 be the value of the, let's see, of the second int, I guess. So we need the second int. Right, now we need to do the compare as we did here. Let's just take like this. So we say t3 is gonna be t1s plus t2, and this is like the new length of the string, and the new length is gonna be L. So new length is gonna be L. So we take the first variable, string field, we add location 2, and we store it here. Okay, and now we have to compare what's the 5 here. Oh, so in now in T3 we have the end of the string. Okay, I mean, sure. We compare it with this. Let's say okay, substr. Okay, substring. Let's see what's next. Actually copying the stuff, I guess. So it's gonna be just a single mem copy. Let's put that here. We're gonna have a single mem copy. The destination is gonna be t1.s, sure. RSI is gonna be plus arg0.value. I mean, let's put in t4 arg0.value plus t4 although I would do it like this. I would say this is t2, this is t3, this is t4. Okay, just to have it the same place. So now we have in t2 we have arg0.value t2, and the length is going to be t3. Okay, add string field and add the second keyword. Okay, so this should actually copy the entire garbage in the thing. So now we have to set t0 value to t4. What's t4? I guess t4 is the length, so we just have to set this guy to actually t3. T3 is the length value. So here we set the length. Good. Then we set this thing, and then we do, let's just copy the rest, because the rest is gonna be similar, I think. So here we set the int, then we set the size, which should be, if I remember correctly, it's t4 this time. t4 minus t1. We do the shifting as usual. Although this is yeah, but that's not really good. Then why I did it twice? I think I forgot to delete it or something. Okay, let's go back to concat. So in concat, I have this extra stuff which shouldn't be there. Right, we set the length, we compute t6 as this weird thing, then we set the size, heap position. So that's, so in did I do a oopsie in here too? No, this one seems fine. Okay, so let's go back to substr. So inside of substring, we have t1 length is this pointer, t6 is gonna be this value, but here I said it's gonna be what, t4. Okay, perfect, because t4 is the new ending of the string, and this can be t5. Sure. Okay, again, here this should be t6, and again I have to check in string just in case. Yeah, this one's good. Okay. Yeah, here it was just a mismatch in the index, but should be good now. Okay, so here we save in t5. Here we set the size from t5. Here we update the heap position to the new heap position. Okay. And here we get t1. So we needed just 6 variables, I guess. So here should be 48. I mean 48. 48. Yeah. Let's check. Wow, it worked first try. That's a new one. So yeah, I mean, this means we have everything should be working. So feature substring. So yeah, I mean, all the test cases that I can think about work. So let's see if the real test works. First likes to eat. I mean, I don't know what it should show. L.print. So it's new list which contains first, and then a new list which contains guy and void. So guy is John Pizza. Interesting. Let's see. So we have a new person. Let's see what new person does. Ooh, this sucks. Person. Well, well. I mean, this is not used, so let me just remove it. Or was it used? Hmm. I guess concat didn't really work. I mean, who here was surprised? I guess that it didn't work first try. I mean, let's try to do guy show like out, outstring hello world. Oh, wait, what did it segmentation fault? What? Wait, this is strange. Yeah, yeah, sure. Let's see. Let's go step by step through this thing and let's see what happens. I mean, first of all, let's see where it crashes, right? So it tries to move into BL something. But how it can segmentation fault on that? Wait, what? What the hell is this thing? I don't remember using Rex add. What? Like I have no idea how it can segmentation fault on BL 0x. What? Is it like segmentation faulting somewhere in my code? Yeah, somewhere. But it's like on initializing stuff, which is interesting. Is it like when it's initializing a person? Yeah, when it tries to initialize the person, what? Okay, that's weird. I mean, we can try to look at the assembly and see what we have. I mean, I guess even person init doesn't do anything. So it should be like default string, right? Okay, wanted to see, dude, like person dot init. That's the function that I'm searching for. Okay, so it says name is equal to n. So it takes the that and it stores it. So that's good, I guess. Like all of this stuff is good. I don't see how. Okay, I mean let's. I mean this is what? I don't know, to be honest. Let's just skip it. So this would be the first function, which I think is init. What? It's not. Something's not good. It's jumping to a random place. Okay, let's continue again. So, okay, if we don't care about that, if we want to look just at this, if we go to the dispatch table, I want to see the dispatch table for bro, what? The dispatch table for a person, where is that? Person, disp. Person, no, disp, tab. Object, string, boolean, main. Wait, but where is the person dispatch table? Okay, I guess. Okay, I was not compiling the right thing. Person, this table. So yeah, I mean it has init right here. So let's see when it tries to call init. So it's gonna put into. So basically this is the method call part of the code. So if we go into assembler.c, I guess it found the dispatch call. So dispatch call. So we should see it pushing the arguments and stuff. So this should be the first argument, I guess. Wait, what? Okay, I guess this is the self. Now this should be uh, the name of the person. I forgot whose name that was. So we have a string. Let's examine the string. I mean, if I remember correctly, it's always gonna be at 20. No. Well, let's not really. Bro, I mean, I don't know what h does. So this is the string, the size, the value is 7. Okay, excuse me, what? Oh, I was looking at the wrong thing. It's in array_x. Okay, so examine 40 from here. So it's a string, size 5. Interesting. And this is the text, and it looks like some. So it's 1, 2, 3, 4, 5. Oh, this is. It's not. What the fuck? It's not aligned for some reason. Um, that's a bit strange. Wait, let me see. Oh, so that string is pizza. Then, because I see 7A7A, and that's what, like 2 Z's. Yeah. So like this is the. We push it, then we push the second one. So this is the last argument. But see, it's not aligned for some reason. Because this gives us the type. This is the size, 5. This is the dispatch table. This is the pointer to the length. This should be the data, but why is here some garbage? Like it looks like then this is the next thing, which is a 5, which has size 4, right? Something like this, but I don't know. Then this is the dispatch table for it and the data or something. But I don't see how it cannot be aligned. Like, I mean, these are constant values, so they are defined here in the thing. They are not living on the heap, let's say. Mm, I see, they are not aligned here in the memory. So is there a way to align this? I guess we can pad them with zeros manually. Assembler.c. So, oh no. Okay, here. I mean, we can try to pad them with zeros. So we can have something like size t bytes is equal to words times. And then we can have size t padding is gonna be bytes minus length. So here, string value db. When we build a str, we have to do something like if padding is greater than 0. No. It's annoying that we have this thing with a comma. Let's say and. Okay, or padding is greater than 0. Yeah. So if the length is not the last element or the padding is greater than 0, we have to add commas. Perfect. So then we have to go up until the padding with zeros. And I guess that should be enough. So in this case, I would say dq0, and here I would just leave. Yes, like that. But we need one extra space for the 0. So let's change this to string length plus 1. String length plus 1. Right, here you need to do length minus 1. Because I want to include the 0 byte also in the padding. So it has to be length plus 1. I mean, it's gonna be an extra 0, we don't care about it. Right, even when we copy it. Yeah, let's see what happens if we compile it like this. So we have 4, 4. Yeah, that looks good. So it's gonna be like 8 easier to count 4 instead of 8. And make sure we have 4 times 4. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So I think this should be aligned by 8. For example, here we only have one character space or something, and then we have 7 zeros. For this one, I think this is an empty string, so it's all zeros. So it's also not really gonna happen that the string is gonna be null. So we can just leave this. Yeah, I think it's never gonna happen because this is gonna be at least 1, which in turn will make this one word. So yeah, this should work. This should align stuff properly. Yeah, funny how I thought that I was done with the C code. Still segmentation false. In the same weird place. Let's see how we get there. Because it just jumps to a random memory address where it shouldn't go. Okay, let's break. So into RBP we put self, I guess. Or like new person, probably. Then now this should contain examine 40x, and now this should be aligned. So these 8 bytes, here another 8, the dispatch table, the pointer to int, the string itself. So let's yeah, it looks like there's the real string. Okay, so it pushes it on the stack. And I mean also the name. Okay, pushes that also. I think this was the object, so we actually take it. Then it adds the dispatch table to it. So let's go back to dispatch call. So here it loads the variable, then it takes the dispatch table into RDI, right? And then it adds 40, which is what if we use Python cheat codes with 64, and if we divide it by 8, it's gonna be 8. Interesting how it got 8, but let's see if it really is 8. Person disp. Zero, 1, 2, 3, 4, 5. Okay, what? Interesting. Because yeah, like that that function is not correct. So we go through the method index. We go through all the classes. Take this thing for the okay, what? So we go through all the classes. And we just try to search for that method name. Doesn't sound good. Like it searches for init. Okay, yeah, so I mean the issue with this one is that if we have another function name called init, it might find this one and try to call to it. So that's the issue here when we do a for loop over all the classes. So we should try to narrow the search a bit somehow. And yeah, so yeah, we might need a way to specify in which class, like not really the type of the dispatch like we tried here, but the like type of the expression, you know. So something like expression type, and it should come from the type of the expression node. Not sure what type this should have though. Right. So we might have to go into the type dispatch call and have here the expression type. Right. So if we go back to assembler, now this is like the static dispatch. So yeah, maybe I should be able to say now something like this instruction expression type. Let's see if anything changes here. So string concat person init, that should be good. But I want to see in main actually. Yeah, so it calls to person init. And here if you call to outString but you don't provide a class and it's self-type, I guess that's also a problem. We have to see how we're gonna fix that. So like maybe the way to do it is to put here self and just call it a day. Like maybe this should fix it. So it's gonna be, where was, I mean outString still goes there, but here it loads self. So I would put here then self type. The type of the expression is self type. That I mean looks good to me. So that we don't have a null there. Right, and now it's self type. So how can we use the method then? Is you can say if let me just zoom in a bit. Str compare between these guys is not true, then we continue, and then we don't even need found anymore. Similar to some other place where I did this exact same thing. I don't remember where, to be honest, but I remember I did something like this. So this is how we check. But yeah, like if we are in self type, how do we search for the method? I think that's gonna be the next issue. But first let's see what happens if we run it like this. Abort called. Perfect. But now at least when we do person init here, where was it? Person init. It's now at RDI plus 32, which is good. But this one no longer works. Outstring. So we need to see. I mean the instruction type is null. Right, it's null, but we should, I mean we might have to convert the self type into the real type though. But I don't know how we can do that here, because the context doesn't really have the log. Well, you know what? We actually have the current class inside of this thing. Current class. I realize that. So if we have self type here, I guess let's say it's an extra case outside of this. So if string compare instruction export type with self type, we have to do something. So it's in the following way. If you don't have an expression, wait. Wait, so no, I actually changed that. So we no longer have expression null. We no longer have expression null, so it's always gonna be self, right? So if the expression type is self type, we have to do something. Otherwise, if it's not self type, we have to not really. Because if you do a static dispatch, doesn't matter what type we have. So only if the dispatch type is null, we can do this thing. So let's say let's do like this. Method index is 0 if we are inside of a self type. I think if we are inside of a self type, we have to do something, and otherwise we do this loop, right? Like it should be like this. If we have a normal dispatch, if we don't have a static dispatch, we have to compare the expression type. If it's self type, then we use, well, I mean, it's still the for loop, so let's go back. Let's go back. So it's still the for loop, but here when we compare this thing, we have to set it. So we have to say something like char pointer export type is equal to this, and if the expression type, well, and here we also compare with it. If it's self type, then we actually do expression type is the current class, right? That's what I'm thinking. So it's the current class. And now when we say this, we can say something like this and see what happens. Okay, so now it no longer complains about that. That's good. So it's person init. Here is gonna say main string. So here when we show this, I would also like to show which type it is. Maybe like as a parenthesis around the initial thing. Okay, let's try to do that. So instead of printing this guy here as the comment, let's go to the switch from up here. So yeah, I added the 3 others code printing in here for the comments. I thought it would be interesting. So let's say we also print the expression type, so it's gonna be ds string builder, like this expert type. So now we should see the expression type in front of the call. So here, for example, is gonna be this in the person class, right? Like it's gonna search for init in person, basically. It's not really that it's the init function from person. Person is like the type of T4, basically. It's like an interface. Here, for example, it's self, obviously because we have self. Yeah, I think I'm happy with this, how this turned out, right? Let's remove the changes we did in main.cl. John likes to eat pizza, and that's what we were after. Man, I'm sure we don't have time to do anything else today, like, but we actually finished everything about the compiler, right? Like it's completely done. Like we just saw the message that should have been printed here, and it has a lot of stuff that happens around here. So yeah, like we actually managed to, do the classic. We managed to get 64-bit executable that prints. Yeah, this is really nice. Really cool. I mean, now the next step would be to get the language to be self-hosted, but now no shot that's gonna happen. There's no chance. So actually we had to fix some of the stuff, but as I said, I think I'm gonna try to do a better build system, like, doesn't really matter, and probably add some Linux syscalls. Yeah, I guess even maybe doing like a Game of Life or something like that. Although Game of Life might be a bit difficult because we have to implement lists and then matrix. Well, we don't need the matrix, we just need lists. So yeah, we'll try to do Game of Life. And yeah, probably we'll have a video like I implemented the compiler for, I don't know, I think it's like 25 days, maybe even more. Here's what I learned. Yeah. But yeah, now it's actually complete. Sure, we can add more stuff to the prelude and improve the build system. That's the stuff that I'm thinking about. And when we are gonna, require this stuff, then when we are gonna when we are gonna do exception handling and stuff. I really started to hate assembly, to be honest. And to be honest, I don't even know what I fixed. So yeah, I I think we are good for this time. The compiler is compiling. What can I say? Yeah, I mean the compiler is compiling, and we are finished for this one. We'll have to play around a bit more with the language, try to get something to do with it, because I mean we have a compiler, we cannot just throw away the project. We have to implement at least the game of life, and maybe some graphics thing. Like imagine being able to do that. Like that's the now that we finish the compiler, now the goals, you know how it is. You finish one thing and you always want the next thing. But yeah, I mean we actually got it. So yeah, thanks for watching the series on the compiler and see you in the next one.